principle behind air conditioning is simple yet ingenious. It involves the removal of heat from indoor spaces and its transfer outdoors. By doing so, air conditioning systems create a cool, refreshing atmosphere that enhances productivity, supports better health, and ensures a higher quality of life. This article delves into the fascinating mechanics of how air conditioning systems work, exploring their components, the processes involved. The basic principles of air conditioning. Air conditioning systems operate on a fundamental principle: the transfer of heat from one location to another. This process involves the refrigeration cycle, which uses a specialized fluid called refrigerant to absorb heat from indoor air and release it outside. The key concepts behind air conditioning include heat transfer. At its core, air conditioning doesn't create cold air, but removes heat from the indoor environment. By extracting heat from inside a space and expelling it outdoors, the system lowers the indoor temperature, creating a more comfortable environment. Refrigeration cycle. The refrigeration cycle is the cornerstone of air conditioning. It operates in four main steps. Evaporation. The refrigerant absorbs heat as it evaporates in the evaporator coil. Compression. The refrigerant is compressed, increasing its temperature and pressure. Condensation. The refrigerant releases the absorbed heat in the condenser coil as it turns back into a liquid. Expansion. The refrigerant cools down as its pressure decreases in the expansion valve, completing the cycle. Humidity control. In addition to cooling, air conditioning systems reduce humidity levels by condensing moisture from the air. This not only enhances comfort but also prevents mold growth and improves air quality. Air circulation. Proper air circulation is essential to evenly distribute cooled air throughout the space. This is achieved using fans and ducts, ensuring consistent comfort in every corner. By combining these principles, air conditioning systems provide efficient and reliable cooling, making them indispensable for homes, workplaces, and vehicles. Key components of an air conditioning system. An air conditioning system is made up of several key components, each playing a crucial role in the process of cooling and dehumidifying the air. These components work together to ensure efficient and effective temperature control. Here's an overview of the main parts. 1. Compressor function. The compressor is often referred to as the heart of the air conditioning system. It compresses the refrigerant gas, increasing its pressure and temperature, which is essential for the heat exchange process. Location, typically found in the outdoor unit. Role, moves refrigerant through the system, initiating the cooling cycle. 2. Condenser function. The condenser releases the heat absorbed from indoor air into the outdoor environment. Location, housed in the outdoor unit. Role, converts the high-pressure refrigerant gas back into a liquid by cooling it. 3. Expansion valve, or metering device, function. The expansion valve reduces the pressure of the liquid refrigerant, cooling it down significantly before it enters the evaporator coil. Location, installed between the condenser and the evaporator coil. Role, controls the flow of refrigerant into the evaporator coil. 4. Evaporator coil function. The evaporator coil absorbs heat from the indoor air as the refrigerant evaporates inside it. Location, found in the indoor unit, often near the air handler. Role, cools the air that is circulated back into the living space. 5. Blower fan function. The blower fan circulates indoor air over the evaporator coil and then pushes the cooled air back into the room through the duct system. Location, inside the indoor unit near the evaporator coil. Role, ensures consistent air distribution throughout the space. 6. Refrigerant function. The refrigerant is the working fluid that absorbs and releases heat as it cycles through the system. Role, facilitates heat transfer by changing state from liquid to gas and back. 7. Thermostat function. The thermostat monitors and regulates the indoor temperature, allowing users to set their desired level of comfort. Role, signals the air conditioning system to turn on or off based on temperature settings. 8. Air filter function. Filters dust, dirt, and other airborne particles from the air before it passes through the system. Role, improves indoor air quality and protects the system's components from clogging. 9. Ductwork and central systems. Function, distributes cooled air throughout the building and returns warm air to the system. Role, maintains even cooling across different areas. By understanding these components and their functions, you can better appreciate how air conditioning systems work to create a comfortable indoor environment. Proper maintenance of each part is essential for the system's efficiency and longevity. How does an air conditioning system work? An air conditioning system works by removing heat and humidity from indoor air and releasing it outdoors, creating a cooler and more comfortable indoor environment. This process relies on the refrigeration cycle and involves several key components working together. Here's a step-by-step breakdown. 1. Warm air intake. The system starts by drawing warm air from the room through return vents. This air passes through a filter to remove dust and debris, improving air quality and protecting the system. 2. Heat absorption in the evaporator coil. The filtered air is blown over the evaporator coil, which contains cold, low-pressure refrigerant. The refrigerant absorbs heat from the air, causing the air to cool down. As the refrigerant absorbs heat, it evaporates and turns into a gas. 3. Refrigerant compression in the compressor. The gaseous refrigerant is sent to the compressor, typically located in the outdoor unit. The compressor compresses the refrigerant, increasing its pressure and temperature. This step is crucial for transferring heat to the outdoor environment. 4. Heat release in the condenser coil. The high-pressure, high-temperature refrigerant flows to the condenser coil in the outdoor unit. Here, a fan blows outdoor air over the coil, releasing the absorbed heat into the atmosphere. The refrigerant cools down and returns to a liquid state. 5. Pressure reduction in the expansion valve. The liquid refrigerant passes through the expansion valve, which reduces its pressure. This pressure drop causes the refrigerant to cool significantly before it returns to the evaporator coil. 6. Cool air circulation. The now cooled refrigerant re-enters the evaporator coil, ready to absorb more heat from the indoor air. A blower fan circulates the cooled air back into the room via ducts or vents, lowering the indoor temperature. 7. Humidity control. During the cooling process, moisture in the air condenses on the evaporator coil and drains away. This reduces indoor humidity, enhancing comfort and preventing mold growth. 8. Continuous cycle. The process repeats continuously until the thermostat detects that the desired temperature is reached, at which point the system cycles off. If the temperature rises again, the thermostat signals the system to restart. This entire process ensures consistent and efficient cooling, making air conditioning systems indispensable for modern comfort. Proper maintenance, such as cleaning filters and servicing components, is essential for the system to work optimally. Energy efficiency in air conditioning systems. Energy efficiency is a critical factor when selecting and using an air conditioning system. It not only helps reduce electricity bills, but also minimizes environmental impact by lowering energy consumption. Here's an overview of how air conditioning systems achieve energy efficiency and how you can improve it. 1. Key metrics for energy efficiency. SEER, Seasonal Energy Efficiency Ratio, measures the cooling output of an air conditioning system over a cooling season, divided by the total energy consumed. Higher SEER ratings indicate greater efficiency. Modern systems typically have SEER ratings of 13 to 25 plus. EER, Energy Efficiency Ratio, evaluates the cooling output relative to energy use at a specific temperature, usually 95 degrees Fahrenheit, often used for smaller systems like window units. COP, Coefficient of Performance, indicates efficiency by comparing heating or cooling output to energy input. A higher COP means better performance. Energy Star certification. Systems with this certification meet or exceed strict energy efficiency guidelines set by the US EPA. Tips to improve energy efficiency. Regular maintenance. Clean and replace air filters every 1 to 3 months. Schedule professional inspections to clean coils and check refrigerant levels. Proper insulation. Insulate walls, ceilings, and ducts to prevent cool air from escaping. Seal windows and doors to eliminate drafts. Optimal thermostat settings. Set the thermostat to 78 degrees, 26 degrees Celsius in summer when you're home. Raise the temperature slightly when away to reduce energy consumption. Use ceiling fans. Ceiling fans help circulate cool air, allowing you to raise the thermostat without sacrificing comfort. Shade the outdoor unit. Place the condenser in a shaded area to improve efficiency. Ensure proper airflow around the unit by removing debris or obstructions. Upgrade to a high SEER system. Replace outdated units with models that have higher SEER or Energy Star ratings.